Okay, let's talk about the other, it just so happens to be in alphabetical order, which, by the way, we're running through all these labs in alphabetical order. So it just so happens that the thing that comes after CRP is going to be ESR. So erythrocyte sedimentation rate. And you also know it as another general marker of inflammation. And the idea behind this, of course, is you take a bunch of red blood cells, you pour them in a column of water, and you see if they stack on top of each other. They're not supposed to stack because red blood cells have a negative charge. The way that they prevent automatically clotting while they're moving around in the serum is that they are able to repulse or repel each other because of their common negative charge. Now, there's a phenomenon that happens when inflammation happens in the body. The red blood cells lose their negative charge and therefore are able to get closer together. They're able to get closer together to stack in this big tube of water to, this is why they call it erythrocyte sedimentation, like sediment settling on the bottom rate. But let's tie it back to the last slide. If they've also lost their negative power to repel, they're also more likely to get really close together in the bloodstream. Wait a minute, what do we call that? A clot. Accelerated ESR is favored by elevated levels of fibrinogen. So we just tied the C-reactive protein, together with the ESR. C-reactive protein, as you just learned, raises fibrinogen. Increased fibrinogen increases ESR. And now do you see the vicious circle that is about to start? The next sentence is about the negative charge, the zeta potential, but I've already explained that. ESR is also elevated in rheumatoid arthritis, just like CRP. Chronic infections, just like CRP. Collagen disease, neoplastic disease, just like CRP. And in anemia. And that's a new one. So what did we just say? If one of your differential diagnoses is anemia, then you might also want to run an ESR. We did mention anemia back with the C-reactive protein, right? We said the body sees inflammation and infection as anemia and hides the iron. I'm sorry, it sees inflammation as infection, and then its mechanism is to cause anemia by hiding the iron. So now once you have anemia, you can see the ESR then goes up. These two are intimately connected, ESR and CRP. ESR can be also low in microcytosis, fancy for small cells. Sickle cell disease, polycythemia, protein abnormalities such as hypofibrinogemia and hypogammaglobulinemia. Zeta potential, we'll move past that. I've explained it in just plain English. Okay, so GGT, the good stuff. I'm gonna have to leave you guys with a cliffhanger because we're down to 3 minutes. So next week is where we will start off with our liver enzymes and GGT, and talk about how the relationships between both of those can help you localize where your biliary or your GI problem might be occurring. All right, guys. You did it one more time. You nerded out with me for a half hour on this stuff. I hope it was helpful. So I will see you guys in 7 days from now. Have a wonderful week out there. Bye-bye.